Good morning for this short pitch for our idea, which is looking to develop new or to screen for new antibody candidates against rapidly evolving viral targets or emerging viruses. As you might know from the experience with SARS-CoV-2, viruses rapidly evolve and they can differentiate in their sequence that they present in terms of antigens. So what you can see here, for example, is the mutational landscape part of it from SARS-CoV-2. And what you can see here as well is that at this time in November 2020, the first monoclonal antibody against SARS-CoV-2 was given emergency use authorization for use in humans. But only 6 months later, the antibody has been rendered ineffective due to rapid viral evolution. And if you think about an antibody development pipeline, at least it's around 2 years, so that's the fastest examples, but it can take up to 8 to 10 years. So if we screen today for an antibody that's supposed to be relevant for viruses that circulate in the population in 5 to 6 years, it becomes basically a statistical task of selecting the right candidate. And here we want to use systems that we developed in the lab that we are currently publishing. Here we use SARS-CoV-2 as a model antigen. We basically present a large library of SARS-CoV-2 antigens on the library, and we screen individual cells against these kinds of antigen libraries. And the system is made in a way that it's biased against antibodies that recognize a lot of different viral variants, a lot of different variants of antigens, and these antibodies we then select and then sequence the recognized antigens and also sequence the antibody and can use these to predict whether the antibody might stay relevant or will become obsolete quite quickly. As mentioned, we have done this for SARS-CoV-2, and just to show you here, that's one landscape for mutational spectrum, which the antibody recognizes here for this specific antibody in this case. And we can basically then use this data together with viral evolution prediction to try to see whether we can find antibodies that mutate or that have some specificities for mutations that might come up in the future. So this would allow us then to select candidates that will stay relevant for future developments. And what we'd like to do in this project is we would like to use this case of SARS-CoV-2, of this model system, to see whether we can develop a platform that we could either use for emerging viral targets or for rapid outbreak response, where we would have basically a mutational library from viruses within the phages. Again, we screen antibodies for cross-reactivity and for the specificity profile. We sort them, we sequence them, and then we try to select the antibodies that might stay relevant either for that specific outbreak or for future variants that might become relevant. So this would then allow us to basically select candidates against future viruses that circulate in the population. So that's one case of the platform that we would like to develop, but of course selection and screening is only one part. So what we're looking for is basically to have a validation and characterization platform attached to this that allows us to basically look at these antibody candidates where we either in infection models, neutralization assays, in vitro validation and so on, where you can basically characterize the functionality or also the predicted aspects using our technology. Because then in a sense, we would establish a collaborative framework that allows us to develop evolution-aware antiviral therapeutics in a relatively rapid pace, and with a broad antigen spectrum. That, in a nutshell, is what we would like to do, and I'm very happy to take any questions and to further explain if anything was unclear. Thank you very much.